How are you guys doing today? My name is Thomas Barone.
I'm Matt Burg.
I'm Hellstrom.
And I'm Miles Soon, and we are the United States Space Force. This is our flagship, the USSS Alpha Omar. It is made out of laser-cut wood, which makes it look simple and clean, also makes it lightweight and easy to fabricate.
So the system is run by a motor-actuated drivetrain, which we use laser-cut motor mounts to attach it to the body. We use 3D printed gears with a 1-to-1 gear ratio, as well as 3D printed wheels. Both of these have set screw channels in order that we may drive screws down into the wooden dowel rod that we're using as an axle in order to have a solid drivetrain. And in addition, we use 3D printed wheel bearings, which we use to reduce friction in the drivetrain in order to make a more stable system.
Rocks are removed by using these spring-loaded flaps in the front. When these flaps meet the lunar ridge surface, they compress and release. And once the robot egresses, the rocks are pulled back. Now the third rock, the one located in front of the lunar module, is accomplished by a back flap behind the robot. It is folded up, hooked to a solenoid, and once the solenoid is activated, the flap folds down, and in a similar manner, rakes back the rocks. The lunar module is avoided through simple ground clearance given in the construction of this robot.
So for the sensor decoys, this system is triggered by this long arm switch. We have 4 laser cut slots in the front of the robot in order that the team may decide which zone they want to target during competition and adjust the switch to the correct height. Once the switch is activated, that will release this solenoid. After that, the balls will roll down the ramp and into the ridge zone that we are targeting. During testing, we experienced vibrations from being pressed up against the lunar ridge, so we made a few modifications. First of which was adding fishing line to the solenoid in order to dampen vibrations, as well as keep the solenoid at a set distance so it wouldn't overextend due to vibrations or release prematurely. And in addition, we added wheels to the front of the robot in order that we may roll smoothly across the rotating lunar ridge zone as opposed to being ripped around by the torque applied.
So the other tasks we need to complete are planting the flag and egressing. So we have this motor here, which is attached to this arm, and we're going to use this arm to plant the flag. So when we're ready to plant the flag, we activate this motor. It'll lift this arm up towards the lunar ridge summit. In order to hold the flag, we have 2 screws attached to the wood back here. We wrap each screw in foam and hockey tape to give us a nice fit around the base of the flag. And then in addition, we have this piece of metal here which attracts to the magnet on the flag and helps hold the flag steady as we raise it. So we plant the flag and then we immediately egress this arm partially, and we have it hover over flag zones 3 and 4 in order to tip other teams' flags. And then when it's time to egress, we bring the arm all the way back and drive the robot backwards to double our flag points for egressing.
Let's talk about the program. What sets us apart from the other teams? The answer is that our program relies on state machines instead of flash equal structures. The result is that we're constantly able to check whether the field is off and the linear plugs no longer get signal, in which case the robot can immediately return to its waiting for signal mode, and we will never DQ because of a program problem. Thank you.